In this video, we'll talk about binary search. First, we'll discuss about the mechanism, how binary search works, and then we'll write a Python code for binary search together. Okay, so first thing you need to remember, a binary search is only possible if the list is ordered, if the list is already sorted. Okay, if it is not sorted list, you cannot do the binary search, you can do the linear search. So it is more efficient and the linear, but remember, it only possible if the list is ordered. Now, how binary search works? Okay, step number one, we always look at the middle item in the list. Then we check if it is the match, means it if it is the item you're looking for. This is the item you're looking for, we are done. Search stops. But if not, then we need to adjust our search, right? What happens? How to adjust it? Basically, if the middle value it is too low, then the item I'm looking for, we just simply ignore the lower half of the list. We only keep focus on the upper half of the list. On the other hand, if the middle value is too high, then the search item, we simply ignore the upper half and focus on the lower half. And we just keep repeating it. Then again, we just find the middle value, then again we check, and then again we adjust our search. So that's basically it. And with this explanation, let's see an example. So here is an example. In front of you, you can see there is a list of number. It is ordered list, and we are looking for the item 99. So first step is find the middle item, right? How to find the middle item? It's simply you just need to add the position of the first item at this point and the position of the last item, right? So 1, 2 all the way to the 9. So 1 plus 9 and you divide it by 2, it's going to give you 5. So fifth element we are looking for, which is 68. Then we are comparing, is 68 we are looking for? Answer is no. So next thing is, if the item I am looking for, is it greater than or smaller than 68? Answer is no. It is a bigger number. 68 is smaller. So that means anything on the left, our item is not there, because remember it is an ordered list. That means this part till here, the item is not there. We can discard from 7, 21, 52, 59, 68. This part we don't need anymore. One more time, why not? Because we've just found out that the number we're looking for is 99 and our middle item is 68, so it can't be on the left hand side anymore. Just discard it. What left for us is this part, 92, 94, 99, 133. Okay, so this is a new list. You can either again give it number 1, number 2, number 3, number 4, and then find the middle value, or you just keep like this, 6 plus 9 position, add them together, find the middle value. You can round it up because 6 plus 9 equals 15. That gives you divided by 2 equals 7.5. You can round up. Remember one thing, if you do round up for one calculation, next time you keep round up. Don't one time round up 7.5. Next time you just 7.5, you make it 8, but next time you might do 7.5 equals 7. Don't do that. Either you round up or round down, right? So you're doing round up, it give us eighth item. Eighth item is 99. So now we are checking if it is the item we're looking for. Answer is yes. We're looking for that number. Search is complete. Now, one thing you need to remember, in this calculation, in this particular example, I give the position 1. I'm starting the position number 1 to 9. You might do it position number 0, 1, 2, 3, 4, all the way down 8 here, right? As you know already, the Python program or other programs actually start the index number from 0. Both way it's possible. You can give index number 0 or you can give index number start from 1. Also, sometimes the questions give you index number already, right? In that case, you need to follow what they give the index number, right? How they write the index number. If it is from 1, fine, you do that way. If it is starting from 0, you start that way. But this is basically it, right? Every time you are looking for a number, you just go find the middle point and then comparing it. After comparing it, you just decide my left half or right, or left half or right half, which part I need to keep, right? Based on that, again you're finding the middle part, and then you just keep doing it until you find the value. If you do done with all of those and nothing left, then of course the number is not there. Here is a little animation. Let's see what's happening here. So in this particular scenario, I can see that it is starts with index 0. Okay, so the beginning left and right is here. Then what we are looking for, target 6, right? So let's wait for it to come to the beginning again. Beginning, target 6, find the middle point, and the value is 8, which is bigger, so we don't need right part. It goes the middle point of the left hand side, then find the middle point again, and then you see, yeah, it is there. Okay, it's really a good animation to see what's happening there. One thing you need to understand, that every time we are discarding the part, so either left or right, we are adjusting our left index and right index. Okay, we need to implement this in Python code, so just understand this part. Every time you're taking off one part, either this side or this side, your left or right is moving. You see that the left and right index are moving, right? So when I write the code, hopefully it will make more sense to you, right? So now we understand how binary search works. We understand how to write the steps for the binary search. Let's write a Python code. Okay, we'll start with a list, ordered list. Let me give the name R, short for array. And my list is randomly, but of course it should be ordered. Okay, let's say this is the list. And the search item is, the item I'm looking for is, let's say 50, with 90. Okay, right. Let's start our code. So we're writing a function, def, and then the name of my function could be binary search, to make it obvious. Now it will take two parameter. One is the name of the list, and another is the item you are looking for, search item. Okay, two parameter we need to supply to get the result back. Now remember now what we discussed just few minutes before. We need to know the left position, another word left index, and right position, another right index, right? So I'm going to create a variable left index, and I can see from the very beginning it is 0. All right. What about the right index? You can make this more shorter, just write down left equals 0, right equals 0. Just I want to make it more elaborate. That's why I'm writing index word there as well. Right. What are the right index? So right one index is this one, the initial, isn't it? And do you know the value of it? This is one way to find it, right? So if you're not sure what I'm just done, len of r means it gives me how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements there. But what is the index number here? Remember, you always start from 0. Python counts 0 as index number. So if this is 0, 1, 2, 3, 4, 5, 6, and 7 here. That means len of r give me 8, but the right index from the beginning is 7. So I just did this. 8 minus 1 give me 7. Alright. 7th position there. If I just add more, obviously it's gonna add itself. Um, Same way is counting what is the length of this and the minus 1. Okay, because we just start our index number from 0. Right, that's done. Now let's write a while loop. While loop, why while loop? Because we don't know how many times we need to do the search, right? That is the reason while loop. Okay. Now, first of all, after while it comes a condition. Question is how long will run this code and when we need to stop. We need to tell program. So my idea gonna be is this. While left index either is smaller or equals. If that happening, then keep running this code. Right? If you think a moment what I just written, left index is this side, right index is this side. All right. Obviously, slowly, they are changing their position, coming in the middle, coming in the middle. But it shouldn't be any moment that left cannot go passing the right value. Okay, you see actually more in depth when writing the rest of the code. But the idea is the left index always stays either smaller or equal to the right index. But it can be greater than that. If that is the condition, then step number 1, remember, find the middle index. So I did the middle index. How to find the middle index? Simply add the left index and right index together, and then we just do the floor division. What is floor division? It basically giving us a integer. Yeah, so if right index plus left index give us 11, divide by 2, if I just write down 1, it's gonna give me 5.5. But if I do this, it's gonna give me integer number, no decimal number comes up with that. Just floor division. So we now know the mid index. What is the value itself? You already know how to do that. The name of the list, and inside the bracket, square bracket, we just write down the index we are looking for. Okay, this is gonna be our middle value. Let's say mid value. All right, so that's how we find the mid value. Now think what's happening at this point. So we find the mid index, it is somewhere here, let's say. Okay, then let's say 7 6 fifth position as fourth position or whatever position is there, we just find that value by doing this. This is the name of my list, and here inside this is the index value. So for an example, if the calculation from mid index find me 6, it give me the 6th position value, right? If it is 5, it give me this. Let's do a quick calculation actually. So mid index, what the result gonna be? Left plus right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, and floor division 2 is gonna be 4.5 is gonna give me fifth actually, right? Okay, rounding up. So fifth position. So array in the fifth position, I'm finding 0, 1, 2, 3, 4, 5, which is 78. Okay, so this is happening right now. After that, the next step you can remember hopefully that we're going to check if the mid value we are looking we just found, if it is same as search item. Is it same? If it is same, simply we are happy with that, and we can return something, let's say found in, maybe saying the position as well, which is mid index. We're saying we already found it in that position. But if that is not the case, in our situation it is not the case, so we need to write another one now, and this is really important to understand. Elif, if the mid value I just got is greater then the search item. Okay, so if the value I'm just getting, let's say I'm looking for 10, but the mid value comes as 78, that means there is no way that 10 is in this side of this. On the other hand, if I'm looking for let's say 123 and my mid value is coming in 78, 123, there is no way it could be anywhere here. Okay, I'm going to repeat this one more time, so when I write this code it will be easier for you to understand. If I'm looking for let's say 9 and first my mid index pointing to 78 and I'm looking for 9, so the comparison said that 9 is smaller than my mid value. That means there is no way this 9 is from here to there, it's not there at all. We can discard that. That means my left index stays in the same position, but my right index now need to come before my mid index. Opposite way. If I'm looking for 123, but my index comes as 78, there is no way my 123 is anywhere here. That means my right index stays as it is, but my left index need to come after mid index. We need to make that adjustment, right? So hopefully you understand that. Take a moment, think of it, pause the video, and then when you're ready, let's write the next line. So I'm saying if my mid value is greater, my mid value is bigger than the number I am looking for. That means I need to adjust my high, right, sorry, it's not high, right index. And I need to go mid index before my mid index. Okay? Else, opposite way, if opposite way mid value is smaller than the search item, that means my left index need to be adjusted and it needs to go after mid index. Okay, remember this two line is really key things to understand, so take a moment before you move forward, pause the video again, think of it, right? That's basically it. And then when we all of things happened, but there is no way you find this value, we just return -1, or you can give any message like not found. Okay, you do like this, and after that our job gonna be call this function binary search. I am just giving the value for my parameter search item, and as it is returning I'm going to write print here. Okay, let me just clear this up so it looks a bit better. Right, so hopefully it will works if there is no typo or anything. We're looking for 90 is here. It should show me found in and then mid index. So what index we are getting it? 0, 1, 2, 3, 4, 5, 6. Let's run the code and it says yes, found is 6. If we just change it, 123, every sixth item here, 6, 7, 8, it should show me found in 8. Now, if I'm giving something out of the blue, which is not here at all, it should show me the return -1. So run code -1, or if you want more elaborately saying not found, it should show me not found. So that's basically it. That's how we need to write a binary search algorithm. Now remember, if you are a GCSE students, you do not need to know or write this code by yourself, right? It's not expected from you that you know how to write this code. However, it is expected that you understand how this code works. It is expected from you that when you see one of the code, you understand each and every line that what kind of search is happening here, right? So if the question comes like this, because over the years I saw some questions actually set the code, set the algorithm in the question paper, and ask you some questions based on that, right? So they're not going to tell you it's a binary search. They will take this word away, and you are the one who needs to read this code and then understand, okay, this is happening, this is a binary code, binary search code. So that much knowledge you should have if you're in GCSE. And of course, if you're in the A level, you have to have know this code. You need to write it by yourself. There is no other way. Okay. So hopefully this video will help you to understand how binary search works and also how to write the algorithm for this. That's all for today. Thank you.